Hello students, good morning all. And myself, I am G. Uma Maheshwar Rao, a new physics teacher. Today I would like to teach friction lesson from 8th state syllabus. So in this friction lesson, we have to know what is force of friction and how many types of frictions are there. We have to understand. To go for that, first activity in the 8th textbook we can see, that is activity number 1 we are going to discuss now. So what is that? Activity 1 means identifying forces acting on a body and the effect of frictional force. This is the first activity given for us in our textbook. Okay, so now see, gently push a book. This is a book and you just push the book. You apply some force on the book. Gently push a book lying on a horizontal floor. We observe that the book acquires certain speed and it comes to rest after covering some short distance, and while it is moving we observe that its speed goes on decreases. So we write here the book is acquiring certain speed and the speed goes on decreasing. So speed of the book gradually decreases. Speed of the book is gradually decreasing. We are observing. Means it is not moving with a constant speed. So children, we are knowing that here the book is not moving with constant speed. So it is not moving with a constant speed. Means it is said to be in non-uniform motion. And so the book is in non-uniform motion, means speed is gradually changing even though direction remains constant. So book is not moving with a constant speed after we are pushing the book gently on this floor. So in the first lesson, that is force lesson, we have learned that an object can be in non-uniform motion when a net force is acting on it. So here the book is in what children, that is the book is in non-uniform motion. The book is in non-uniform motion, and from the force lesson we know that an object will be in non-uniform motion when a net force is acting on it. So some net force is acting on the book. That is called some unbalanced force is acting on the book. So from the force lesson we know very clearly that an object can be in non-uniform motion when a and net force is acting on the object. Net force is acting on the object. So, and it is not moving with a constant speed. That you remember, children. So, now net force is acting means we can identify the number of forces acting on it. So, let us examine. So, let us examine. So, let us examine the number of forces acting. Let us examine the number of forces acting on the book. So now I want to identify the number of forces acting on the book. Okay, students. So for that I will draw the free body diagram of the book. So that is, see children, see students. See students, this is our book. This is our book, and it has some mass. It has mass means it has the weight. So weight of the book, that is called W. So mass of the book will have certain mass. So mass into acceleration due to gravity, weight is acting vertically downward direction. But the book is not going. The book is on this horizontal floor, and this book has some mass. It has mass means it is attracted by the, what is that children? It will be attracted by the, what is the children? Earth. So earth will attract this book. When the earth is attracting this book, it is being attracted by the earth, so it will have some attractive force towards the earth, that is called mg. But it is not coming down means floor is exerting some force on the book. And according to the textbook, this is the normal force. Okay, and we are pushing the book, means we are pushing the book, means this is the applied force. So this is the applied force. No, leave it children. So we pushed the book and we left it. We pushed the book and we left it. And the book is stopped after covering some distance. Means this is the frictional force. And this is the direction of motion of the book. So direction of motion of the book. See students, here I want to find the number of forces acting on the book. So the number of forces acting on the book, I want to find in the horizontal direction and also in the vertical direction. So find, see children, first I want to study the number of forces acting on the book in the vertical direction. So vertical direction. So in the vertical direction, see children, gravitational force. So that is the first one is gravitational force. gravitational force or weight of the book. You can call it as gravitational force or weight of the book. Weight of the book. And the second force is normal reaction force exerted by the flow. So means normal force or normal reaction force. So that is N. And see children, in the vertical direction the book is not in motion. So it's not moving up or down. It is in vertical equilibrium. It is not moving. So the net force in the vertical direction, so we can call F net. So net force in vertical direction. Net force in the vertical direction is 0. Net force in the vertical direction is 0. Net force in the vertical direction is 0 means, so weight of the book, just a minute sir. So weight of the book, so weight of the book W and normal reaction force N, the net force will become 0. That means we will write W is equal to N. So weight is equal to normal reaction. If you want to write mg also, you can write it. So now we can study in the horizontal direction, in this direction. So we'll study in the horizontal direction. So I want to study now in horizontal direction how many number of forces acting on it. And see children, in the horizontal direction speed of the book is changing continuously. Speed of the book. Speed is what happening students? Speed is changing continuously. Speed is changing continuously means speed is decreasing. We can say that speed is decreasing. Speed is decreasing gradually. So speed of the book is decreasing. And when an object is moving in a horizontal direction and its speed is decreasing gradually means we say that book has acceleration. So book has acceleration opposite to the direction of motion. So book has acceleration A opposite to its direction of motion. Opposite to its direction of motion. So means the book has deceleration in this situation. So book has acceleration, but that is, so it has an acceleration and speed is decreasing means it has acceleration opposite to the direction of motion. Means book has deceleration. So book is in deceleration. deacceleration, that is called deceleration. Book is said to be in deaccelerated motion. Means someone is stopping the book when the book is moving on this, when the book is moving on the horizontal surface. That is, floor applies a force. That is, floor applies force on the book, and that force is stopping the moving book on the horizontal surface. So that is the net force acting. So means net force acting on the book, that is in the direction of force applied by floor, in the direction of force applied by the floor. Means the floor is applying the force and stopping the moving book. So that force we call it as frictional force, or simply we call friction. So the net force acting on the book is the force applied by the floor. Floor applies a force on the book. The book is moving like this. Floor is applying a force in this direction, and that force is called frictional force, or frictional force or the friction, which is the net force only. Because out of three forces, weight and normal reaction, so weight is downward direction, normal reaction upward, it is balanced, and this force is not balanced, it is an unbalanced force. Out of all these forces, the net force is in the direction of force applied by the floor opposite to the direction of the motion of the book. So that force we call it as frictional force, and that frictional force only stopping the book, that is also called friction. So we can see another activity, next concept. Hi Abhyasians. So the next concept we are going to see in the friction lesson, and now this concept is very important for this entire friction lesson. So that is lab activity. Okay, so in this lab activity, so what is our aim? You see children, the aim is understanding nature of friction, and the concept of static friction. These two things we are going to see in this lab activity. One is understanding the nature of friction, and the second one is static friction. So we will see the definitions of static friction definition. We will see static friction definition we will get from this activity. Static friction, and also we will get sliding friction. So sliding friction. So what is static friction? We will get in this activity. Sliding friction, or another names of this is sliding friction, or another names of this is kinetic friction. Kinetic or dynamic also. Kinetic friction or dynamic friction, anything you can call kinetic friction or dynamic friction or sliding friction. So now we can see clearly this experimental procedure we can see now. So for this, see children, take a small toy trolley. This is a small toy trolley, and now take a small wooden block and keep it on it. Now tie an inextensible string to the toy trolley, and that string passes through the pulley, and the other end is connected to a weight hanger, and this is the weight hanger. We can connect weights, we can keep the desired number of weights in this weight hanger. So take a small toy trolley and keep a small wooden block on it. Tie one end of an inextensible string to the trolley, and that passes over this pulley, and the other end is connected to the weight. This is called weight hanger, and we can keep the desired number of weights in this weight hanger. So these are called weights. And now take a small weight and take a small weight and put in the weight hanger. And observe the motion of the trolley and the wooden block. What happens, my dear students? Does the trolley and the wooden block move? Do they move left side? Yes, your answer is correct. So the trolley moves towards left. So the trolley moves towards left side, moves left as shown in the direction like this. Okay, so the trolley is moving towards left, and the wooden block, that is the block, what happens is, children, block is at rest. Block is at rest. These two are moving. Block is at rest with respect to the surface of the trolley. Block is at rest with respect to the surface of the trolley, and the block is in motion with respect to the table. With respect to the table, this entire system is moving. So the block is in motion with respect to the table, and the block is at rest with respect to the trolley when you put a small weight in the weight hanger. Now increase the weights. So increase the weights and observe the motion of the trolley and the wooden block. So we observe that. So when we increase the weights, so the entire system moves with a bit of a greater acceleration, and the wooden block may fall backward, but the trolley is trying to stop falling this in the backward direction. So it is stopping that to fall in the backward direction. Means the trolley is exerting some force on the surface of the trolley, exerting some force on the wooden block and trying to keep it rest. And this trolley exerting force on this wooden block, and it is trying to keep it at rest. It is trying to keep this one at rest, So now still you increase the weights. Still you gradually increase the weights in the weight hanger. So I am increasing the weights in the weight hanger. So I observe that when I increase the weights in the weight hanger, acceleration of the trolley, so along with the wooden block increases. So at a particular, so now identify the limiting acceleration or limiting weight. Now I want to find limiting acceleration, or what do we call, students? That is called limiting weight. So, or limiting weight. So find the limiting acceleration or the limiting weight. Up to what weight the entire system moves with the common acceleration. That maximum acceleration I want to find it. And if you add any more weight, the trolley, the wooden block on the trolley falls backward direction. It comes into motion in the reverse direction. It means that, so it is trying to fall backward direction. It means that there exists a relative motion between the surface of the trolley and the block. Up to that, what is that limiting acceleration or the limiting weight? This trolley is trying to keep the block at rest, and that force is called as frictional force. So now we can see the definition of frictional force: the force which opposes the relative motion. See, my dear students, what I am underlining. The force which opposes the relative motion of two surfaces of the bodies in contact is called frictional force. That is called understanding the nature of friction. So we are understanding the nature of friction. So here there is a friction and it is trying to stop the relative motion of this wooden block in the reverse direction. So up to particular weights. So that is called as frictional force. So we came to know that. What is the frictional force? We came to know that. Now, and we can also do like this, see children, take iron, so what is that? Iron block and rocks. Take iron block and rocks of same masses and keep it on the trolley. So iron block and rocks of same masses I am taking. I am keeping them separately on the trolley, and I would like to find the limiting weight. Then I won't get the same limiting weight even though the masses of iron block and rocks of same masses are kept here, and you are keeping so weights in the weight hanger, and we are identifying the limiting weight. I think children, you know what is the limiting weight. Means we will keep on adding the weights in the weight hanger, and we will try to notice at what weight the object here tries to comes into motion in the reverse direction. That weight we will call it as limiting weight, and the acceleration in that situation for this system is called the limiting acceleration. That I am going to calculate. That will be different for same masses of different objects, which are iron block, what is that children? Iron block and rocks also. Now iron blocks and rocks, same mass I am taking, same mass I can consider, and then next situation I'll consider different masses also, different masses. And every time I will identify this limiting weight. And now you apply a grease to the bottom of this wooden block, or just you apply grease to the top of the trolley surface and put a wooden block and identify the limiting weight. We notice that the limiting weight will be reduced, decreases. For less weight only, it comes into motion in the reverse direction. Means when we apply the grease or some lubricants, the frictional force between these two, the frictional force is a force. Frictional force is just a force which opposes the relative motion of two surface of bodies in contact, you are telling, and that frictional force reduces when you apply any grease material. Okay, students, so in this activity what is frictional force we have seen, and up to the limiting weight we notice that these two objects are moving, means the trolley is applying some force on the wooden block and trying to keep it rest, and the block also applies the same amount of force on this trolley. Okay, and that force is called as static friction. So what is static friction? Definition we can see now. Static friction definition. Static friction is the friction which comes into play when the surface of the objects are in contact with each other. Surface of the objects are at rest. Static friction is the friction. Static friction definition we are going to see now. So static friction is the friction which comes into play when the surface of the objects which are at rest, so relative to each other. So those two objects must be at rest relative to each other. That is about the static friction. And now we can see sliding friction. Sliding friction is the friction which comes into play when one object moves on the surface of the other object. Sliding friction is the friction which comes into play when the surface of one object moves relative to the surface of the another object. So that is about sliding friction. Sliding friction is the friction which comes into play. So what is that? Which comes into play when the surface of one object moves relative to the surface of another object. So that is the definition of sliding friction. Similarly, we can see the definition of static friction. Static friction is the friction which comes into play when the surface of the objects are at rest, when the surface of the objects which are in contact or at rest relative to each other, when they should be at rest. So that is about static friction and sliding friction from the activity 1 and activity 2. Okay, students, next class we can see variation of friction. Thank you. Okay, students, now the next activity number 2, observing the variation of friction, we are going to discuss now. So for that, consider a heavy box which is kept on a horizontal floor and pushed with a small force. We just apply a small force on this heavy box. We observe that the box does not move. Now gradually increase the applied force. Now we are pushing this heavy box with increasing force. Still the box does not move. Why means, so the box still does not move because the frictional force also increases accordingly with the applied force. As we are increasing this applied force, this is the heavy box and we are pushing and gradually increasing our applied force. So we are increasing our applied force gradually. The opposing force also increases accordingly with the frictional force. With this frictional force, with this applied force, the frictional force also increases accordingly with it and it balances that. So the box does not move. But see, whenever there is a box on the floor and you are trying to push it with small efforts and increasing efforts, we are observing it is not moving. Means some force is encountered in the opposite direction and that is balancing this applied force. That force we call it as the frictional force, and the object here it is rest means we call it as a static frictional force. Okay students, so it's a static frictional force and means, so this frictional force also increases accordingly with the applied force and that is balancing this force, you know that, but that frictional force can increase up to particular limit only. So the static friction can increase up to particular limit and beyond that it cannot increase. So that's why it is self-adjusting, it adjusts by itself and it can increase to particular limit only. That's why we call static friction the self-adjusting force. Whenever applied force is there, the static frictional force, okay, is adjusted in opposite direction. So fine children, but there is a limit to this static friction. It can increase up to particular value. Beyond that it cannot increase. So whenever our applied force is more than the limit of the static friction, means you are applying the greater amount of force. So the static friction is less than this applied force, then the block comes into motion. That is called observing the variation of friction, how it is increasing with the applied force. When applied force is 0, frictional force is 0. When applied force is 10 Newton, frictional force is 10 Newton. When applied force is 50 Newtons, frictional force also 50 Newtons. So let us assume that for these two surfaces, the frictional force can develop up to 100 Newtons. Means if your applied force is 10, frictional force is 10. If our applied force is 20 Newtons, frictional force is 20 Newtons. Applied force is 50 Newtons, it will be 50. If our applied force is 100 Newtons, it is also 100. At that stage, it is ready to move. It is just began to move. When our applied force is 120 Newtons. But for this interlocking, friction can develop up to 120 Newtons only. Beyond that, it cannot develop. So definitely, the heavy box or the block comes into motion. This is observing the variation of friction. Thank you, students.